How much work battery can do is going to depend on how it delivers the electrical charge. When you say deliver it, you're going to start talking about time. So while we have NF being the quantity of electrical charge in coulombs, because we had moles and then we had coulombs per mole, we need to know something about how quickly that can happen, and that's going to involve time. So we also have a unit called the ampere. Normally we just say amps, but an ampere is 1 coulomb per second. Or you could say that a coulomb is 1 ampere second, but an amp tells you how quickly you're going to deliver that charge per second. And then the coulomb volt being a joule means that if we're thinking about that, we could say ampere times second times voltage is joules. And then it turns out a kilowatt hour then is a unit of energy, because the kilowatt is power and then times an amount of time, and then you get back to energy. So watts are a unit of power. We have a question though. It says that they're going to do some work here on magnesium metal. They want to create some magnesium metal by putting electricity through magnesium chloride. There's a reaction at the cathode, which is red cats, right? So that's where the reduction happens. The positively charged magnesium ion will take in 2 electrons and it will become magnesium metal as a liquid, because all of this is being done in a molten form, so it's all very, very hot. The question is, how many grams of this magnesium metal are produced if you have a certain amount of current, okay, in amperes? Then it's allowed to occur for 4 hours and 45 minutes. It says, assume all of the current is consumed by the half reaction. So we're not including any losses. We're just saying what's going to happen. And yet, what are we asking for? We're asking for a number of grams. Wow, there's a lot of stuff going on here. I'm not quite sure what to do about that. However, I do notice one thing right off the bat. This says 4 hours and 45 minutes, and everything that we talked about up here was in seconds. So I am going to switch that. Let me just say that 4 hours and 45 minutes. I want to say what that is. The 4 hours, oh, well, I could say that was 4 3/4 of an hour, right? So I could say it's in hours. And then I could say 60 minutes per hour and 60 seconds per minute. And if I do that, I'm going to find out that I have a very large number of seconds. It seems like it should be helpful in creating some of this stuff, right? I also have a piece of information here about the amperage. Okay, so I could use this thing about coulombs being the amps times the seconds, right? Okay, so now that I know the number of seconds and I already know the number of amps, I can figure out how many coulombs it's going to be. The 63.7 amps, I can replace the amps with coulombs per second, because that will make more sense to me. And then I will say times the 17,100 seconds, and I'll end up with too many sig figs, but I'll keep them with me for a while. Wow, that's a lot of coulombs. Okay, that sounds like it's going to be very effective, right? So now I know how many coulombs there are. What else do I do with this? Well, you know what? I look back at this equation and I realize that it is using 2 electrons every time this happens. So if I want to make 1 mole of the magnesium, it's going to require 2 moles of electrons. All right, that's useful information. Coulombs, I have coulombs. Oh, yes, the quantity of electrical charge in coulombs is NF. Well, this is the N. That's N. And I'm going to have to memorize that crazy F, aren't I? Okay, F. 9.65 times 10 to the fourth coulombs per mole of electrons. Okay, what can I do with that? Well, I'm really wanting to say that I want to know how many moles of magnesium, because if I know how many moles of magnesium, it'll be easy for me to find out how many grams, because that's just using the molar mass, and I'm used to doing that. I'm looking for the number of moles of magnesium, and I have some of these weirdnesses here, okay? So what do I have that I know? I know I have the 1.089 times 10 to the sixth coulombs, and that's going to get used in some way. Oh, yeah. Coulombs. I need to flip this. I'll flip F. So I'll say a mole of electrons is the 9.65 times 10 to the fourth coulombs. That'll take care of that. Now this is moles of electrons, not moles of magnesium, but I just got through saying this, right? So I will keep going. I have 1 mole of magnesium for every 2 moles of electrons. And I am interested in moles of magnesium. So 1 mole of magnesium for 2 moles of electrons. Okay, so moles of electrons is gone. When I calculate that, I'll have my moles of magnesium. Okay, that sounds good. When I do that, oh, I thought I had a lot here, but as it turns out, it didn't end up being nearly as much as I expected. And then my last step is just, I wanted to know the number of grams, so I'm going to take this 5.64 moles of magnesium and multiply it by the molar mass, which is 24.3 grams per mole. And I'm going to get 137 grams of magnesium metal. Wow. Gee, I thought this was pretty impressive. It seemed like it was a lot of coulombs. It looked like it was a long time, and yet it's only 137 grams of magnesium. This shows you why it is so energy intensive to create a pure metal from one of its ores. And this is why it takes a lot of energy to create anything new from the sources that we have. That's why we like to recycle.